Hey, you guys, welcome back. Let's go ahead and finish the study guide. So, look at the next one. We just finished over here. We just talked about this big hint right here. When you multiply or divide by a negative number, you must flip the inequality sign. So, we have to keep that in mind. All right, whenever the number that's attached to the variable is negative, we have to flip the inequality sign. So, let's look at this one. Step number one is always still to eliminate the constant. I'm going to eliminate that 10 by subtracting 10. 10 minus 10, it's a 0. Zero's out, which is exactly what I want. I'll subtract 10 over here. Now I'm left with x divided by negative 3 is greater than 10 minus 10. That's just 0. I'm going to multiply both sides by negative 3. Both sides by negative 3 because that's the inverse operation here. That reduces down to a 1. I'm left with x. 0 times negative 3, that's just 0. And now look, I multiplied by a negative 3. It's a negative number. I'm going to have to flip this sign. So x is now going to be x is less than 0. That's what I'm looking for here. Let's go and graph this. And remember, just because it's 0, we can still graph it. So I'm going to put 0 right here. 1, 2, 3, negative 1. Go find your 0. Leave the circle open because there's no equal to. And x is any number that's less than 0. All my numbers less than 0 are going to the left. Now let's look at this one. This one's kind of special, okay? This one actually might be a double flip, all right? That sounds so complicated and crazy, but we already know both methods for when we have to flip the inequality sign. The first one is when the variable is on the right side. It might just be easier if we go ahead and flip it to put it on the left side, all right? Negative 3y minus 14, exactly as it's written. Negative 8, but I'm going to flip the inequality sign because if it was facing the negative 3y side, it should still be facing that side when I flip it, all right? Because I haven't done any math stuff. All I've done is rewritten the inequality. So now, let's go and solve this. I'll eliminate the constant by adding 14 to both sides. That zeroes out. Add 14. So now I'm left with a negative 3y is greater than or equal to negative 8 plus 14. That's just 6. I'm going to go and divide both sides by negative 3 because that's the inverse operation. And look, I'm dividing by a negative number. When I do that, I have to flip the sign. All right, so I'm going to flip it the other way. 6 divided by negative 3, that's negative 2. So now I'm just left with y is less than negative 2. You know what's interesting? We had to flip it twice. All right, we started here. We flipped it once to get here. And then we flipped it again to get back to where we started from. All right, we had to flip it twice. And we're actually just back to where we started from. So y is less than negative 2. Let's go and graph it. Negative 2. Negative 3. Again, I'm just filling in the number line any way that I want as long as I have the negative 2 here, okay? So I'm going to go and find my negative 2. I'm going to go and close the circle, and the reason I do that is because I have this equal to underneath that sign, all right? Y is any number that's less than negative 2. All my numbers that are less than are going this way. All right, so let's go and scroll down. Let me give that an erase, and we'll scroll down a little bit. Let's look at number 10 and 11 and 12. Let's see. Let's get back on the pen, move that out of the way. So number 10, in which of the following inequalities would you have to flip the inequality sign? Choose 3 of these. And a big hint, you don't even need to solve these inequalities to know if you're going to have to flip it. There's an easier way. If the number that is attached to the variable is negative, I have to flip it. So let's look at this. My variable is h. Is the number attached to negative? Yep. I'm going to have to flip that sign. Let's look at the next one. Here's my variable. It's an x. Is the number attached to it a negative? Nope. So I won't have to flip that one. This one, is the number attached to the variable negative? It sure is. That w has a negative 7 that's being divided by. I'm going to have to flip it. This one, the variable is a b. Is the number that's attached a negative? It sure is. I'm going to have to flip that one too. Let's look at the next one. The variable here is a y. Is the number that's attached a negative? Nope. It's positive, so I won't flip that one. This one, the variable is an m. Is the number that's attached a negative? Nope. It's positive. I won't have to flip that one either. So the only ones I'm flipping is when the number that's attached to the variable, the coefficient, is negative. I flip the sign. All right. Let's look at number 11. How do you know when you need to flip the sign? There are 2 main reasons. Please explain them below. The first one is when the variable is on the right side. You have to flip it. For instance, if I had 2 is greater than x, I want to flip it and get the variable away from the right side and move it over here to the left. All right, so I'm going to have x and 2. I'm going to flip those around. And when I flip those around, I have to flip the sign around too. If the alligator was still eating the 2 like it was here, it should still be eating the 2 over here. All right. And the second reason, whenever you multiply or divide by a negative number, you must flip the sign. And this one is a requirement. All right. This one up here, you don't have to technically. It's not a requirement. If you left it as 2 is greater than x, that's just fine. That's correct. This one, however, is required. You must flip it. All right. For that inequality to be true, you have to use the opposite sign. So let's go down to number 12 right here. Let me give that an erase. We're going to scroll down. All right, let's look at this one. It says Mr. Gann solved the inequality below, and he showed his work every step of the way, like a good math student always does. But he made 2 mistakes. Explain the mistakes on the lines below. So here's an inequality. Let's go through and see what we should do first. So I have to eliminate the constant. It's minus 4. I'll do the inverse operation. So I'm going to add 4 to both sides. Oh, he did that. Perfect. That checks. Then he's going to be left with negative 3x. Good. Greater than or equal to. Good. Negative 13 plus 4. That's negative 9. Good. That's all still good. Then he needs to divide both sides by negative 3. Oh, he did that. Divide by negative 3. He did that twice. Perfect. That is eliminated. That reduces down to a 1. Perfect. I'm left with x by itself. Negative 9 divided by negative 3. Wait, that's not negative 3. Negative 9 divided by negative 3. That should be a positive 3. All right. Again, if you try and do this in your head, it's easy to make little mistakes like that, especially with sign errors. So use your calculator. It's there for a reason. And this one, look, he divided by negative 3. Whenever we divide or multiply by a negative number, I have to flip my inequality sign. So this should really be x is less than or equal to 3. That is my actual solution set right there. So he should have flipped the sign. And negative 9 divided by negative 3 is positive 3, not negative 3. So if this is my correct solution, let's go and graph it. I have 3, 2, 1, 4, 5. I'll go find my 3 up here. I'm going to close the circle because I have that equal to sign underneath. X is any number that is less than 3. All my numbers that are less than 3 are going this way to the left. All right, let's look down here. Please write the inequality based on the graph. So whenever we write these inequalities, I know I need some kind of variable, an x, and I know I need the number on the line. All right, so the number that is circled is going to be my number that I'm comparing it to. This one, in this case, look, it's not written under here, but I know that that's really a 31. 30, all blank, and 32. 31's right in the middle. So now I have to figure out what kind of symbol am I going to use. I only have 4 choices: less than, greater than, less than or equal to, or greater than or equal to. When the circle is open, I know that there's no equal to. So it's got to be one of these. Now, all my numbers are going to the right. That's saying that all the possible solutions are greater than 31. So x is greater than 31. Let's look at the next one. I know I need an x. I know I need the number that I circled. In this case, it's a 9. And now I have to go and figure out what symbol am I going to use. It's a closed circle, so that means it's one of these down here with the equal to sign. Let's see. The arrow is going this way, so x is all the numbers that are greater than 9. So greater than 9, and my closed circle means an equal to underneath. X is greater than or equal to 9. This one right here, I have an x. I need an x always. I need the number that I circled. In this case, it's a 2. And I need a symbol. When we have an open circle, it's going to be one of these 2 at the top. There's no equal to with it. So it looks like x is all the numbers that are greater than because it's going to the right. The numbers get larger as they go to the right. So x is greater than 2. And then whenever I write these, I always double check and make sure that it makes sense. X is greater than 2. I have my 2 up there. I have an open circle. Good. X is greater than all the numbers that are greater than 2. Yep, that's going to the right. I did it correctly. Always double check your work here, okay? This one, I need an X. I need the number that I circled because that's what I'm comparing X to. Then it's an open circle, so I know there's no equal to. And I'm going to the left. As we go left, our numbers get smaller. So X is all the numbers that are smaller than 9. And those are the inequalities that I would write for these, all right? Let's scroll down and look at the next few. I'm going to give this an erase so I can scroll. All right, let's see. Let's look at number 14 right here. All right. Admission to the DeSanta Carnival costs $4. Then each game costs 50 cents. If Grant can spend no more than $10, which inequality shows how many games he can play? This one's multiple choice, so that's nice. I can look and see which one makes the most sense. And if I'm looking through my choices, it looks like the only difference, I have the $4 to enter the carnival. 50 cents per game, good. $10, it's all the same. The only thing that changes is the inequality sign. So, looking through this, let's see. Where are some keywords I could use? So, which inequality shows how many games he can play? That question right there is always the variable. Whatever question is in your word problem, that always answers, that's always what your variable goes with. How many games he can play? So where's my X going to go? With the $4 for the admission? No. With the each game cost of 50 cents? Yeah. That's why I have 0.50X. That's how I know the X goes with that 50 cents. So he can spend no more than $10. So he could spend $10. He could spend $9.99. But he can't spend $10.01. He has to spend less than $10. But let's look at our choices. Looking over here, I know it can't be equal to. At least not equal to by itself, all right? And I'm looking for a sign of less than, like $9.99, or equal to. So I'm looking for a less than or equal to sign, and that's this one right here. This is saying that $10 is the most he can spend. He can't spend any more than that. So if that's our inequality, I'll come and write it over here. And we're going to go and solve it down here. Less than or equal to $10. So these are decimals, but the same rules still apply. I have to eliminate the constant first. The constant here is this $4, 4.00. I'll subtract 4.00. That zeroes out. Subtract 4.00. I'm left with 0.50x is less than or equal to 6.00. I'm going to eliminate whatever is with the x. I'm going to divide here because that is the inverse operation. So divide both sides by 0.50. I'm left with x is less than or equal to 6 divided by 0.5. $6 divided by 50 cents. That's 12. Whoops. So x is less than or equal to 12. That is my solved inequality. So let's go ahead and fill this in on our number line. I'll put the 12 somewhere. That seems like a good spot. 12, 13, 14, 15, 11. So I'm going to go find my 12. I'm going to close the circle because I have that equal to underneath. Then x is any number that's less than 12. Just like that, going to the left. So what this means is that he can play 12 games or less. He can play 12 games and still be at that $10 mark. He could play 11 games and still be underneath that $10 mark because he can't spend any more than that $10 budget he has. All right. So these are more of a test of your logic than your math skills. You just have to try and think, if he can spend no more than $10, what kind of symbol would I need? All right. So anyway, I'll do the last few problems in the next video, and I'll see you guys there, okay?